I will be starting shortly. Please stand by. I hope everybody can hear me, and welcome. Welcome to Microcontrollers with kingernorth. This is episode 30. We're going to do multiple stepper motors with Arduino and CircuitPython today. So let's get right to it. Let's have a look at what we're going to be playing with today. So I'm going to open up my camera zoom just so you can see the first board we're going to be playing with. So right here is nice and simple. I have a single stepper motor running on an Arduino Uno, and we'll be running through that program. So that's where we're going to get going today. But we're going to take some closer looks at what we're doing. And right now I just have a jumper installed on there, so I don't have to hold the push button down. So I hope that works for everybody. So I hope that you can hear me. And if you can, go ahead and put a comment in the chat. That would be great. All right, so we're going to get going. Let's get on to our main page here. So this is what we're going to be working with today, and we're going to be working with some Arduino code. So let's have a look, and this is our typical blank sketch that we're going to start with. So already we got somebody there. Hey, oh, garbled. Now, I should have all my other sources off. I don't know why I wouldn't. Let me just check a couple of things. Nope, that microphone is off. It's garbled. I shouldn't be getting it through the other computer. Let me check. Okay, is that working a little bit better now? I've turned a couple of things down. You can give me one more comment. That would be great, Walter, and good morning. Okay, just waiting on Walter there. I'm sure he's going to type in for me. I've tried to make sure everything is working the way it should be. And I hope that's okay. Still can't tell. He hasn't quite responded yet, but we'll get there. Oh, there he is. Okay now. Okay, I think I turned enough things off. Boy, is it ever picky when you got multiple computers running. Okay, we don't want that feedback loop going or garbled, so let's just continue on and let's see what's happening now. So this is where we're going to start. We're going to start by getting a single motor running. So let me just pull this jumper off of here, and we'll see that it stops. And I'm going to go in detail about the circuit, and we are going to go to a dual stepper motor setup, but we want to get through the single motor first just to understand it. So what I've got here is I've got 4 push buttons. From the top, I've got counterclockwise, I have clockwise, and then I have a couple of limit switches here. So this is a little bit harder to do. If I tell it to go counterclockwise and I push the limit switch, it will stop it. And I can let it go and it'll go again. I can press the other limit switch, it doesn't. So that way, if you have an end travel position, you can put a physical limit in and you can control your circuit that way. Let's just move that in the picture a little bit better. And we'll be able to see it. So we're going to build the code to get this one working first, and then we're going to expand it into 2. So let's have a look at the actual wiring we're playing with today. So here's the big circuit. So here it is. I have a Metro board here, which from Adafruit, which is the same as an Arduino Uno. It's exactly the same. It uses a different chip. It's a little bit faster, but it works and it looks like an Uno when you plug it in. So there's no difference in your code. It uses the exact same code, and everything is here. It even has the same pinout pattern as what the Uno has, so no difference. I have here my buttons, and that one says clockwise, although I think it's counterclockwise. Yes, it is. So I have these backwards right now, but that doesn't really matter for what we're doing. We have clockwise, we have counterclockwise, clockwise limit, counterclockwise limit. And then I have a controller board on here. Now, on this board, and I'll take a better look at what's on this board, we'll see that this is a ULN 2003A chip. And that is the chip that's on the board. That's basically what's on those boards when you buy them. It's, oh, it says garbled again. Jeez, I don't know why it does that, Walter. Let me see if I wiggle the plug a little bit. See if that gets better. I'd really like to know why it goes garbled and why it doesn't. It seems really strange to me. But, so we're not getting the echoing, we're getting garbling. I just can't figure that out. I've checked everything before. It keeps come and go. Alright, so this ULN 2003A is the driver chip. You can use a standalone chip, or you can buy it as part of a board. And there's lots of these out there. And there's different manufacturers, a couple major designs. And we're going to see how that goes. So this is your basic 5-volt step motor. Nothing fancy about it. It's got a big gear reducer. That's why the shaft's not in the middle. And basically, to make this thing work is we send a pulse down one of these 4 yellow wires from the Uno into the chip, and it pulses the output. To connect this, all it needs is the 4 inputs. It needs a ground and power for the chip. This power is also feeding the power to the coils that are inside of here. Inside a stepper motor are 4 coils, and those 4 coils are wired back to the 4 pins in here. So this works like a big switch, very fast switch. So that's what's going on inside. So let's have a look at the actual program. We're going to build that up, and I just need to get my mouse into the right spot, turn that page off. We're going to start with an empty sketch. I hope you can understand me, and if not, please just try to follow along. So the first thing we're going to do, I've opened up a brand new sketch. I'm going to go File, Save As. So let's do that. Let me go File, and I'm going to come down here, and I'm going to Save As. And I'm going to save this in my electronic show for today, so it's not in the right spot right now. I will move that. Let's get back here to Documents. There it is. We'll come down here to Electronic Shows. As you can see, there's a couple here, so down here to Multiple Steppers. And I'm going to give this a name at the bottom, which is just off your screen, and I'm going to call it Show underscores stepper 1. So when I do that, up here at the top, it created that name, Show Stepper 1. So that's what we're going to use for today's. We're going to try and keep this simple. And I already have some code written, so I'm going to be copying and pasting a few blocks, but I'll type some of it in. I always like to start at the top of my programs with an opening comment. So I'm just going to go in here and I'm going to go Show underscore stepper 1, and I'm going to put who the author is, and today that's me. You can put in your own name when you create your files, and I might put in a quick comment. This is a demo of a single stepper motor and control. So really basic, but it gets the point across. As usual, when we're doing these things, I like to include any helper files. So I like to put that listing in here. Include any helper files. And for today's, we don't need any for the Arduino. The Arduino has everything built in that we're already going to need. We do not have any additional files to add. So we're going to move on down, and we're going to have to start creating some objects and variables. So create objects and variables. So we're going to need this because we're going to have to assign pins. We're going to have to do all that good stuff. There is a fair bit connected on this board down here. We do have 4 push buttons. We do have 4 yellow wires that go to this board. So we do have multiple connections that are connected back to the Arduino Uno. So let's go ahead and I'll just show you the start of this. So I'm going to use a, it's called SM1 pin. So for stepper motor 1, and that's the pin, and we're going to make that equal to connection 5. If I go back to my big diagram, let's have a quick look. We'll see that on this diagram here, pin 5 goes out to the first stepper pin wire, which happens to be this top position on the chip. If we're looking at the board, when we get to the board view, and that's way down here, so let's zoom in our camera. Way down here on the bottom, we can actually see on this left-hand side, right behind those yellow wires, there is in 1, 2, 3, 4, 5, 6, and 7. We don't use 5, 6, and 7 with this. We're only going to use 1 to 4. We also have some lights on here that are going to tell us which pin is active pin right now, and then this is the connection out to the motor, which includes the 5-volt power lead and the 4 coils coming back. And they're just wired to the first 4 spots on this chip. So that's all there is on there. You can actually get your own. You don't have to buy a pre-made board. Let's go back to our coding. So once we've created the first pin, and we can add a comment about that, basically what we're going to do is we're going to add the other 3 pins. So let me go ahead and make this simple, since this is the same code. Here, magically, I've typed it all in really quick. So here we have the 4 pins from the stepper motor, and they're connected to pins 5, 4, 3, and 2 on the Arduino Uno, and I've just put down here that where they're connected to. So pin to drive the ULN 2003A. So that's what those 4 pins are. That's what those pins are doing. The next thing I want to add into this program, I want to include some code right here on code for the 4 push buttons. So again, I'm going to make myself a little bit easier. I'm going to copy and paste. So in here, I've created my push button up, my push button down. This could be clockwise and counterclockwise. Up and down work as well. Up and down just helps me tell which one's which. And I've got them connected to pins 11 and 12, and these connected to pins 6 and 7. So that's what I've done. And you could use it to raise and lower. I thought of this when I was writing this. I was thinking of a hook on a crane. So if you had a crane and you were hoisting, or a hoist, you could lift something up and lower something down. So this was the idea behind this. Then what we do is we go from there, we have to create the next part. Now what we have to do is when we're going to use this push button, we're going to add a little bit more code in here. So I'm going to create some nice space in my rungs. And what we want to do is we want to be able to tell if these buttons have been pressed or not. So in order to do that, what I do is I have to create some variables for these push buttons. So I'm just going to show you what that is and talk you through it. So I'm going to set the initial state for each of the inputs. So I have my push button up, which I use the same name. I just added the word state after it because I want to know whether it's true or false. Now I put all these in as true by default. And the reason for that is something that we've done many times in this program is we use input pull-ups when we're going to create it, which means there's already 5 volts on the pin, and we actually only have to ground the pin in order to show a difference in the signal. That way we don't have to run power out to the push button, we only run ground. And then the return wire going back to the input pin. That way whenever we push the pin, we just push it to ground. So we're always looking for the opposite state. So they start out as true because we're going to set them to 5 volts high. So we're going to do that. Makes that nice and simple. The other thing I'm going to need to add in here, and there is a couple more. I have a couple more things that we're going to use in here. And very simply, that's a little bit wider. So this is the counter, because we're going to keep track of which coil we are going to press, or which one we're going to energize at a time on the stepper motor. That helps set our direction based on which one we press. The other thing I've done is I've added a delay in here. And the delay is the time between each step. How fast do we want it to turn? And we can speed up or slow this down depending on whether we pick a number based on what we have. For this example, a minimum of 2, and don't forget this is going to be timed, so it's milliseconds by default. We're going to have 2 milliseconds between every step. And it has to be at least 2 or more, otherwise you can start running into problems on an Arduino Uno. There's a speed issue here, and if we try to do it at 1, it'll probably work. If we try it at 2, it will work. And the big thing is if you have comments in here to see what's going on, you need to get them out of the code in order to see it, if you're using any print statements. And that's our serial monitor. Every once in a while, up here on the top right, we use the serial monitor on the code page, and it gives us feedback of what's going on. So we're going to do it both with and without this. So a little piece of note that I've created, and I put this in my main file. If you email me or send me a note through the YouTube site, I will send you a copy of this, provided you give me an email address to send it to. And what I've done here is I've created a little note that I'm going to stick in here. And basically this just says, note to speed up the stepper motor, comment out all of the uses of the serial monitor. So if you've used the serial monitor anywhere, you just want to comment them out, because that has to talk through the USB cable, and that is definitely a lot slower than this motor can run. So we have to kind of allow for that. So now we're going to get into the setup. So in the setup, the first thing we have to do, so we're going to go into this setup. I'm going to copy it. I'm going to paste it in place of this note here because I already have a note for it. And I can back that up. There we go. Sets the pinout modes for all the inputs and the outputs. So this is the normal thing that we do in Arduino. Once we've attached some items to it, we have to say, hey, is this pin going to be used as an input or an output? So our first 4 pins, which are the pins of the stepper motor itself, are going to be set up as outputs. The 4 push buttons have to be inputs, and we use input pull up so that we don't have to wire in a resistor to go with them. Just makes life simple for us. And then I've added another couple little pieces of code in here in the setup file. This is a little longer setup than maybe we're used to. So I'm going to copy that. Let's go down here, and I'm going to paste in the next piece, and let me scroll to it. This is going to use the serial monitor. So I'm going to be able to show you on the serial monitor what's happening when we're creating this initial program, just so you have an idea of what happens, because we're not going to put it into the second program. So we're going to make this pretty simple. So in here, I just start my serial begin on my monitor. I start with a blank line so that it just comes down. Then I put in my count value, and I put in whatever that value on that counter is. So if it's 1, 2, 3, or 4, I just want to know what is it currently. That way I know where it is on the steps. And here's one more little piece of code that will actually help you out. So let me copy this. And I'm going to put this in here. Let me just bring that back. And if you remember up here, I put in a note that said, hey, must be 2 or more for the time, my time delay. So check and adjust the time delay if required. I put in here a little check in here. So if by accident you put 1, 0, minus 30 in that time value, and it says here, if delay time is less than 2, then delay time equals 2. And all I've done is give it so you don't go below the minimum. If you happen to put in 1,000, in other words, 1 second, you'll get 1 second delay between steps. But if you put in something too small, it will at least give you the minimum of the 2 milliseconds to make life easier. So that's just a check. It really doesn't do anything for the most part because it shouldn't be a problem. So that takes care of all of our setup. So our setup is complete now. This is everything there. We can see it all in one page now. I have my setup. I've adjusted my output pins. I've created my input pins. I have put in a message to keep track of the counter so I can see it. And I've actually checked to make sure that I haven't put in too low of a value for my speed. So all of those things are allowed in there. That brings us into the main loop program. The main loop is broken down into a few steps, and we'll go through those. So let me go and Again, I'm going to make my life easy. I'm going to take this first line and I'm going to paste over it. And the first thing that we're going to do, since we have 4 push buttons, is I want to know if I'm pressing any of those buttons. So what I'm going to do is I'm going to take the state of this and I'm going to make it equal to the reading of that particular pin. Now, by default, since I used input pull up, all of these are going to be true. If I press a button, it goes to false, which will then set the state to false. So that's the way I'm going to read it inside my program. Now, the next part is we're going to build. And this one I'm going to explain. I'm going to take some time to build this. Believe it or not, we're actually not that far from being completed in this project. It's not an overly taxing program. It's very repetitive, and we'll see how that works very shortly. So the first thing I'm going to do is I'm going to come down here. I'm going to create some space down at the bottom, and I'm going to throw this in. And what I have in here is I put in a comment for this, what this next block of code is. This allows the stepper to rotate clockwise, and I believe it's actually going to be, actually it might be on that pin, so that's the one we're going to look at. To rotate clockwise when the up button is pressed and the up limit is not pressed. That's what that does say over there. So what I've done here is I've created my conditional statement for my if. So I created my if and I said, if not, push up state. In other words, I am pressing the up button. And up limit state means it's going to be true since it's input pull up. True is meaning not pressed. Then go ahead and do a step move. And I have a little program written to help me keep track of this. And I'll show you what that subroutine is. I've actually created a little subroutine to get it out of this part of the program. And then I go in here and I go to my serial print so I can look at it on the monitor. I take my count value and I put in my counter number. So I actually put in the number 1, 2, 3, 4 so I can see it going. And then I increase the counter by 1. So I'm going to start with position 1 the first time through. I'm going to then increase it to position 2. And then the next time I'll go to position 3 and then to position 4. And I'll show you what happens when you do it again because we don't want to go to position 5. We only want to go from 1 to 4 for our steps. So that was to go in one direction. To go the opposite direction, the code is almost identical. And this is actually going to be very close to being a copy and paste even in your own programming. I've created this. So now this allows the stepper to rotate. And I could have put, instead of here counterclockwise, it's actually down. When the down button is pressed and the down limit is not pressed. So again, just like I look for the up ones here, I'm looking for the 2 down positions here. I am also going to call this subroutine called step move. I'm going to print that same value out. And then I'm going to, instead of increasing the counter by 1, I'm going to decrease the counter by 1. So I'm going to go backwards through my steps. And that's going to make it nice and easy. So that's what's happening there. And then we just have the last little bit of code here. And there's actually only 2 little tiny blocks of code left. So I'm going to come down here and I'm going to put in a piece of code right underneath this. So the main loop is almost done. It says this makes sure that the count number from 1 to 4 only. So if the count number is greater than 4, in other words, I'm using this counter plus plus and I go to 5, it's going to say, no, start over, go to 1. If the counter goes less than 0, so if we're going in the other direction down, and we've gone less than 1, it's going to make it 4, so it can keep counting backwards, just through those 4 numbers. And there is one little last line of code to put in here, and I do mean a line. Remember we created a delay variable up top? Well, we need to use that. So we're just going to come down here, I'm going to paste that in, and back up to the top, read buttons again, and then go through and do what it says. If I'm not pressing any buttons, it's not going to move. It only happens if you're pressing the up direction. And I'll show you how that works. So right now, we're going to add a little more code in here. We have to add that subroutine. I haven't forgotten about it. So basically what happens here, I push my up button. So I'm going to push my up button. There's an up limit. If I press it, it stops moving. If I let go of it, it continues to move. If I press the down button and I press the down limit, it stops. When I let go of it, it continues to move. So I have all those functionalities working. Now we're going to add the subroutine. So let's add the subroutine as one big block, and I'll walk you through it because it's actually fairly simple, but it does take a few lines to write. So we're going to come down here. I'm going to paste in here. So I'm going to create this subroutine. Subroutine to make the stepper move. So void step move, that's the one I've been calling in my two if statements up above for forward or reverse, up or down, however you want to rephrase them, clockwise and counterclockwise. And what I've done in here is I've just created 4 if statements. So if the counter is equal, 2 equal signs mean is equal, not make equal. So this is equal to 1. Then do this. And what it does, it sets the pin values for my 4 outputs. Basically what happens here is I put them in and I say, hey, pin 4, I want it to go high when I'm in step 1. When I'm in step 2, I go pin 3 high, I go pin 2 high, then I go pin 1 high, and that's it. That's all it does. So these are all the exact same code, cut and paste, change what you want it to check for, and then put the high in the appropriate pin. And only one pin of the 4 is live at a time. So you liven up one coil at a time. So that's basically what we're working at. So that's the simple code. Now, when we do this, I can compile it, and I can make it run. So let's go ahead and do that. I'm going to validate it to make sure I didn't forget anything. So up here on the top left of the Arduino screen, let's validate. Let's make sure it is validating. And it's going through, it's compiling the sketches. The way it does that, it will come up with an error if there's any problems. So far, nothing happening. It still says compiling, which it will. It takes a little while to compile a new program the first time. They're a little bit quicker once you've done it. And it says, no, it's not happy. A function definition is not allowed here before the closing brace. That one's void loop. Void step. Well, it does work. What did I miss on my other program? Did I miss one of these? When I copy and paste, sometimes it's easy to miss things. Okay, what's different? Because that's exactly what I have in my program that's actually running on it right now. Just for the sake of argument, I'm going to validate this once again and see if it does it again. It shouldn't have. That was strange, but hey, strange things. Hard to see the code. Oh, I'm still getting that same error. Not sure why it's doing that. You're having trouble seeing the code today? Let me just see. Let's see if I can bring... I'm going to make that window a little bigger. That's about as big as I can make it on the screen. Hopefully that's a little better for you. What did I do different? Including Whole screen blurry. Oh, that I have no idea why that would. I'm actually up at my maximum resolution and it looks good on my preview, Walter. I'm not sure what's going on with that. I'm getting a good broadcast. I don't know what's happening. I'm not dropping any frames. Oh yes, there were a few frames dropped early on. I don't know why. Something must have slowed down at one point. Seems to be okay now. Yours might have dropped resolution while you were doing it, Walter. Yeah, I think Felix is right. You could just go back in and tell YouTube you want to go back to the higher rate. It did drop frames for a little bit, and I think there might have been an issue at that point. So I'm wondering why this one's giving me a problem. I'm going to do something I don't normally do. Is I'm basically going to copy out this whole program. I probably missed a copy or something somewhere. Let's see if this fixes it. Because this would not be nice if Arduino's not happy with it today, although that's the program that's actually running on it. And I do have a way around that if it comes down to it. And it is possible I missed something while I'm doing it that messes it up. See, it's done compiling, so I probably messed up one line somewhere, copying and pasting. Probably my fault, but that's okay. Oh, yeah, auto-res changed to 144. That's what happened, Walter. It did drop a few frames for a moment, so there was probably some interference on my line, and we dropped a few frames. But other than that, we seem to be working again. Okay, so now that we have this working, I'm going to go in here to my tools at the top. I'm going to make sure my port is connected, and I'm going to go to the COM18, which is my Arduino. I'm going to go ahead and upload this. So this, we're actively uploading the file. And we're going to see it compile. And then we're going to see these little lights up here blink up by my finger when it's actually uploading. So we'll see that happen shortly. And there they go. They're blinking. And they finish blinking. So I'm going to open up the serial monitor. And I'm going to bring that down so you can see it because it's not in the right spot on the page. As it never is. It just never likes to be. So there's the count. So now I'm going to go over here and I'm going to press this button. And when I press that button, we can see the numbers go by really fast. But if I let go, we'll see the numbers went in an order. So depending on which way I go here, I can get 1, 2, 3, 4. And it looks like actually I might have changed my assignments on my pins, which is why it changed. Let me move that over. Let's look at our pin. Oh yeah, you know what? Up should be 12. This one should be 11. Let's validate that again. Actually, we're going to upload it completely. This should fix my clockwise and counterclockwise problem. So we're going to wait for that to finish loading up. It's loading up. It's going to upload now. When we do, we should see this monitor hopefully will update. There it did. It put in that blank space that I was talking about and then added the count 1. And now as I push that, we go from 1, 2, 3, 4 back to 1. And we continue that pattern. And we are going clockwise now. And from here we go counterclockwise. And we'll see that the numbers count down from 4, 3, 2, and 1. So that's basically what happens in here. So I'm going to turn off that serial monitor, but that's what happens in our code. So just to recap this very quickly so we can move on to the dual, because I know you're going to want to see 2 stepper motors running, because this is where it gets more interesting. And I'll explain why very shortly here. So we create the pins, we assign pins for the stepper motor. The 4 pins, we assign our inputs as needed. We preset our states for our push buttons in our program. We preset a counter. We preset a delay time. In the setup, we set them to outputs and inputs as needed, and we use input pull-ups because they're simpler to use. We like the fact that we don't have to connect a resistor to them. We print the starting values of the counter. We check to make sure we didn't set our delay time too low. Then we run the program. Read our 4 push buttons. I know this is a really fast recap. Then basically we tell it to move clockwise, providing we are only pressing the clockwise button and we are not pressing the upper limit. Same thing for down. If we want to go counterclockwise and not pressing the down limit, it will go in the proper direction. We make sure our counter doesn't go beyond 4 or below 1. If so, we reset it to the proper value to continue counting in the direction we're going. And we add our delay time. In the subroutine, we have 4 blocks of code here. When the step is equal to 1, the step's equal to 2, 3, or 4, the counter itself. And we just turn on the appropriate high and low settings, and only 1 pin high at a time going to the stepper motor, so we only energize 1 coil at a time. And then it's all fixed up. So that's how basically it works. So that's our program for a single stepper. What we're going to do is we're going to go down to a dual step system. So I'm going to very quickly, I'm just going to unplug this Arduino. I do have to take this motor that we have here because I only have 2 stepper motors right now. I've been using all the rest up. So I'm going to move that board out of the way. And I'm going to bring in a board with a lot more stuff on it. And that's this one here. So we're going to rearrange my window. You're going to see what's going on here, and I'll show you what's in there. I plug that stepper in. Let's bring this stepper into view. We're going to try and get everything located here somewhere where we can see them. And we'll probably adjust the camera a little bit. We're going to need a little more real estate, but that's okay. And what I've got in this case here, we got a little bit more, and let me just plug this in. And we're going to go ahead and I'm going to show you what's on here. But to do that, we're actually going to go to the drawings, which is going to make life easier. And I'm going to update and show you the new drawing now. So what we're doing is we're working with this image up here. So let me just, there's an extra line here on my code page. Let me turn that off for a moment. So here we are here on our picture. So what we have is we have the same Arduino Uno that we just used. It's not wired up any different, except that we're not wiring to these ULN 2003 down here. What I've done is I've added an item called an expander. And this is a really nice simple thing that we can add in here. And this gives me 16 inputs or outputs on my board very quickly. The problem we had here is if I connected one of them, I needed to use 4 of these pins. I used 5432 to connect to the first stepper motor. The problem is 6, 7, 11, and 12 were being used by my 4 push buttons. I don't have very many pins left. So in order to get around this problem, I added on this expander board which talks over I2C. So this connects to the communication lines, the SCL and the SDA pins. And it has a positive and negative for power. It has the 5-volt plus and minus. And it's connected to this board. And this is a board made by, this one happens to be made by Adafruit, and it's the AW9523 expander. And it also has changeable addresses on it. So I can actually have up to 4 of these connected at one time. Each one of these has 16 inputs and output pins. And actually it's 16 pins, and they can be programmed for either inputs or outputs. I'm using them as outputs, and what I've done is I've taken the first 4 that are on here, which are not the first 4 by number, but they just happen to be by location, and I connected them to my second stepper motor. I took the next 4 and connected them to the first stepper motor. I actually have 3 pins here, plus 1 on this side makes 4, and another group of 4 there that I could program. If I really wanted to, I could have taken all my push buttons and wired them into this expander as well. but I left them connected to the Arduino Uno. What I've done is I've freed up a bunch of pins here. Having these extra spots means I could actually put 2 more stepper motors on here. And I don't need any additional wiring back to my Uno. If I added a second expander, I could actually bring that up to 8 stepper motors. If I put all 4 expander boards on here, I could actually have 16 stepper motors controlled by this Arduino Uno. There's no way I could hook up 16 stepper motors directly to a little Uno. There's just not enough pins. Even a Mega would be starting to push its ability with that many pins. And a Mega has a lot more connections than this. So the only practical way of doing this is by using something like an expander. You're thinking maybe that I could have used a shift register. Yeah, I could have, except shift registers only do out, and they are a little pickier in how they update. This, I can update any pin at any time without affecting the rest. It's much simpler to use. And the fact that it could be used for inputs and outputs. So it makes life a lot simpler in the long run. So I think this really helps. So we're going to go ahead and we're going to look at the program that I have for that. So what I'm going to do is I'm going to open up my Arduino Code again. This is still the old program in here. Well, I'm going to swap it out. So what I'm going to do is I'm going to go into my notes here. I'm going to do a copy and paste. This program's a little longer because it does involve 2 stepper motors. And I didn't write it the most efficient, but I'm going to explain what's going on. And again, these are available if you want a copy of my code. I'm willing to share. You just send me a note and include an email address, and I will gladly send you a copy of this code. So let me just go in here, highlight everything. So we're just going to do this nice and quick. There was, what, 105 lines of code there. If I paste this, it now goes up to 173. So let me scroll up to the top of this and let me walk you through the code. And I'm going to do this because this name's already been used. I like to keep my show files separate, so I'm going to go File, Save As, and I'm going to just change this to stepper 2, just to keep it separate from my original file. So this is my dual stepper test. And again, I'm going to this time I will need a helper file. Because I'm using this expander board, this board way down here, and I can actually show you one a little closer. In fact, maybe I'll do that. I have a brand new one here in a package that I haven't used yet, so I'm just opening up that package. And we'll send the camera and make it go crazy here, because I'm going to put this right there and see if it'll focus. Come on. There we go. So there's an expander board. On that expander board, we can see down there in the bottom left, it has a V in. That's our 5 volts in, or 3.3 on this case. This one will automatically switch between them. It has a ground connection, an SCL, an SDA. It's got an interrupt and a reset. So those are all things on there. After that, the rest of the pins are used around the edge that are used for the input and output selection for the 16 pins. Beside it, there's also a voltage in button. So if you're going to use it for something special like an LED, you can actually connect an LED to this board without a resistor. It has built-in resistors for that. Also in the middle there, you'll see an A0 and an A1. Those are spots you can solder. You can either leave them empty like that one is there, and that's the default address, or you can actually start soldering and jumping them out. And if you only solder A0, you get a new address. If you only solder A1, you get a different address again. If you solder both A0 and A1, you get a 4th address. On the end of this one here, there's also these connectors. These are Stemma QT connectors that they're using. They were first brought out by SparkFun. Adafruit has adopted these. And these are handy if your board also has, your processor also has a Stemma ST pin connector. See if that'll refocus again, maybe not. And you can put in a little 4-pin connector in there. So we'll just leave that down out of the way. And that's basically what that is, though. Very simple board to use. I've soldered some pins on this first one so I can put it into my breadboard. Nice and simple. Let's have a look at our code that we have going on here. So, in our helper file, we're going to include this board. And this is the Arduino version of it. So I just went into my in here to Sketch. I went into Include Library, and you just go into Manage Libraries, and you download it from there. You just search for the AW9523, and you'll find a driver by Adafruit that you can just install into your system, and then you've got access to it. So this is the Adafruit AW9523, and what we're going to have in here is we're going to create the object for it. So I'm going to create the object and it's just Adafruit underscore AW9523 space, and then this is the name of the object, AW. So that's what it's going to be called from here on in, is AW. Anytime I reference something on that board, the object is called AW. That's just a short name. And if I had 4 of these connected, I could have AW1, AW2, AW3, and AW4. I could create multiple AWs. Or whatever name you want to call it. You can call it Expander if you like typing a lot. The next thing I've done is I'm going to create my objects and variables as needed. So the first thing I need to do is I need to create a bunch of these ULN 2003A connections to connect my motor to. And I'm going to connect these pins, but I'm not using a straight integer anymore. What I'm using is an unsigned integer 8-bit. And basically what that does, it makes it a very small number. It's also happier with I2C when you're transmitting over I2C. It gives you a data type that matches what the I2C is using. This is very important in Arduino to make sure you use the right data types. When I used integer before, it could actually create a much larger number, and it didn't really matter. Now that I'm doing it, this is going to be assigned to the board location, so this is fine. And these pin locations here are the pin locations on the expander board, not the Uno. So those are pin 15, 14, 13, and 12, 7, 6, 5, and 4. I've actually haven't used 11, 10, 9, and 8, or 3, 2, 1, and 0. So I still have 8 pins available to me. The next thing I did was create push buttons. I've used the same 4 push buttons wired the same way, but I've given them different purposes. So the first 2 are for stepper 1 to go clockwise and counterclockwise. Push buttons, the next pair are for stepper 2 to go clockwise, counterclockwise, and clockwise. So I've actually done this based on how I want to press the buttons. So these are Uno addresses. So if you notice 7 and 6 were used here, well, they're also used here, but this is on the Uno. Up here, for the coils, the stepper motors themselves, that's the AW addresses. The next thing I want to do is I want to create initial state for those push buttons. So the same as what we did before, create them as true. My names are a little longer now because they're named differently. I have 2 different counters because I track the 2 stepper motors separately, because one's counting up, one's counting down, and they could be in different positions. I have a delay time of 10 here because I have no serial monitor ports in here, so I brought them down to a reasonable speed so we can see it work properly. Then we get into the setup. The first thing we have to do is turn on the expander board so we actually can address it and recognize it. So what we do here is we go if not AW begin. So just like we use serial begin when we're going to turn on the serial monitor, we're going to turn on the expander board. The expander board is called AW.begin, and that's its default address, 0x58. If you were to actually use the other addresses, I think they become 59, 60, and 61. And then I have a while 1 delay 10. And what happens here is until it reads that expander, it says, well, wait here, pause this as long as I need to in the setup, and then use the expander. Then once the expanders, I can see the expanders, so the I2C has talked to it now. Then move on to the rest of it. Now I set up my outputs, and since these all start with AW.pin mode, these are on the expander board. So these are going to be my expander board. They're all set for outputs. These ones here are all set for inputs. So that's what I've done here, is I've created all these, and they're input pull-ups because they're no different than I did the first time. They're connected to the Arduino Uno. And again, I checked that my delay time is not too short. Then we're going to look at the main loop. Main loop here, I start out just like I did before. I have 4 push buttons. I'm going to read the 4 push buttons and set their state. That's all I'm doing in the first part of the program. Then what I've done is I've created 4 if statements in here. I think we can see them all. Let me move that slightly. There we go. Move stepper 1 clockwise. So what I get is I look for that I'm pressing the 1 button for clockwise but not counterclockwise. And then I can do step 1 move. So I've actually created a subroutine called step 1 move, and I send it the current counter position. And then I increase the counter position when I leave here, and I continue through the rest of the program. If I'm not doing anything else and only holding that 1 button, I continue to do this, and each time I send the updated counter number. And I do that. The second button, I want to turn stepper 1 counterclockwise. So I now check to make sure that the counterclockwise is pressed and not the clockwise button. So if I press both buttons, nothing's going to happen. And then I'm going to say, okay, move it, and I'm going to count down through my stepper. Pretty straightforward. It's very similar to what we did. I don't have the print statements in here, so it only takes up 3 lines. And then I have stepper 2 clockwise and stepper 2 counterclockwise, which are the same as principle as stepper 1, except these are the ones for number 2. Very simple. The next little group here, here's where I set my counters. I don't want to ever go over 4 or under 1. So I go from, when it gets above 4, I say make it number 1 so it can count up again through it. If it's less than 1, bring it back up to 4 to let it keep counting down. And I do that with both counters. I set my delay time, and then I added a little extra thing here. So what happens here, it says turn off the coils of steppers when not moving. One of the things you may notice in the old one is that the stepper board on here, one of these LEDs on that board, it's hard to hold it in place there, was on all the time. Now I don't want any of them on to draw less power. It also prevents the stepper from warming up, because it does warm up over time, not significantly, but we don't need to waste power if we're not doing it. So what I've done here is if neither one of the buttons are being pressed, just set all the pins to low. Therefore, there won't be any coils energized going through here. As simple as that. The subroutines themselves are basically like they were before. What I've done is void step up 1, and this time I brought in the integer called count because I'm actually sending that value, the step position, to the step. And then I'm saying if count is equal to 1, equal to 2, equal to 3, same as before, same code. The second one does the exact same thing, except it's only for stepper 2. So I've just isolated the pair from each other. And that's it. That's exactly how that works. So if I go in here and go to Tools, let me find my port because it's going to change. It's port 29 now. I'm going to go ahead and I'm going to compile that and upload it to this board. Now, it was working before I did this, so it should work now. We're going to find out. So we're just waiting for that to finish. It's compiling still. A little green bar down here is moving up. Oh. Why is there... Oh, what happened to the end of the code here? Something got messed up down here at the end of the code. I may have clicked the button wrong. Oh, I didn't copy it all in. How is this one longer? If count. Oh, you know what? This is code left over from before. When I was pasting it in, I didn't paste over everything. There we go. Let's try that again, compiling. Gotta hate that when you forget to highlight something or when you're copying code. You gotta make sure you get all of it and leave nothing extra behind. And I did in this case. I left something behind. This is what happens on live shows. We get to see these little errors, which is not a bad thing. So there we go. Now we're uploading it. And we're uploading it. The lights were flashing. So if I reach across here and I press the first button, nothing happens. What did I not hook back up? Positive, negative, positive, negative. Okay, this is going to be me. Oh, I did something backwards when I was doing it earlier, obviously. SCL. This will do it every time. Let's see if that'll fix it up. I'll probably have to upload it again. It looks like I may have had my communication lines backwards, and you'll see why in a little bit, why this is an issue. Because I actually am going to modify this board for CircuitPython. And it's compiling. We got to wait for it to upload. Okay. Yellow is SCL. Yellow is SCL. SDA. SDA. Those are connected the right way around. Okay, what did I do different? We have power on this board. We are communicating. Now see, this is what happens when you don't have your serial monitor connected. Those look the same. Those look the same. Okay, this is troubleshooting on the go here, so let's figure this out very quickly. It's probably a connection issue for me. But I should have been... I'm just checking to make sure my ground and power haven't pulled out anywhere. They seem to be all connected. Everything seems to be connected. So now we're going to learn how to troubleshoot very quickly on here. So if I go down here into my setup, I can actually put in a new line here, and I'm going to go serial dot I'm typing that wrong. Of course I am. It's capital S. I'm capitalizing the wrong part of the code. $9,600. So we're going to do that. And then we're going to say, we're going to put in here a print ln. We better add the word serial in front of it so it knows what it's talking to. Serial dot print ln. And I'm going to say here not connected. And that's what it's going to say in there if for some reason it's going to do while 10 and it's going to delay and it's going to put that in. And once it's connected, I can put down here is I'm going to put in a serial print. ln for a new line. We're just going to add a little comment in here is Loaded. So now what we're going to do is I'm going to upload that. As soon as it's uploaded, I'm going to turn on the serial monitor and we should see that. We'll see what happens. Gotta love troubleshooting on the go, because I do want to get to my CircuitPython example. Okay, that's uploading. Okay. And I'll show you the serial monitor, and it says loaded. So it did load. So it got down to the loaded part. So according to that, that's loaded. Oh, and look at this. Now it's working. Okay, so if I press the first button there, it goes there, that one goes there. This one goes here, that one goes there. So what happened differently, I'm not sure. All I did was add in a couple serial comments. I can actually press two buttons at once. I can make both motors turn at the same time. You can see those arms turning. And let me show you what's happening with those lights. This is one of the changes I made on here. So if I hold this over here like this, you can see right now there's no lights on for that servo. If I press the button, the lights flicker very fast. And in fact, let me change hands. You can see that those lights are flashing and the servo's moving. When I let go, all of these lights turn out on this board. Therefore, I'm shutting off the power to all the coils. So that's what does that. So that takes care of that. So that's exactly how this thing works. So it's actually very usable, very friendly, and it does the job. Again, I'll make all this code available to you. Don't forget about that. But I want to show you one last example here. And I want to just show you that this can be done in other languages, and I can do different things with different languages. So I'm going to just turn off that code, and we're going to go look at some other code. And the code we're going to be looking at is for this one here, which is CircuitPython. For CircuitPython, we're going to bring in another board underneath here. And this is the little, if we look at that one there, that's the QTPY that we've used before. Waiting for it to focus. Very small board, hardly any pins on this thing, but we're going to make this work with it. And this just shows you that you can use very, very tiny boards with this stuff to make this stuff work. So let's have a look at the diagram that we're going to be using this time, because again, we've had to use a different type of connection. So we're going to go back up here, and we're going to have a look at this diagram. And what I've done is I've actually taken this diagram up at the top, and I've converted it for this one. Look how little connections I got to make down to this board. I'm going to bring down my SCL and my SDA, my I2C. I'm going to bring down my, so that's the blue and the yellow wire on this side, by the way, is the communications. I'm going to bring my power and ground down to this one to feed off of its USB. And then I'm going to take the power for this part and I'm going to feed it to the USB. I'm not going to do these buttons at all. In fact, I have one button already wired up down here. So let's have a look when I make that change. So that's what it's going to look like. Now you can watch me mess it up as I try to convert over to it. So we're going to start by removing these two wires up here. That's the yellow and the blue. And I do have these color coded. And we are going to try and connect these to the proper leads. The yellow is going to go to the SCL, which is that one. And the blue will go to the SDA. So I've brought those two leads and connected them to those two spots on the chip. I'm going to take this power leads for this expander board, and I'm going to run them down to the USB on this chip because this is the one that's going to use them. And then I'm going to steal these power leads up here, my red and my black, that are powering the servos themselves. And let's just make sure we get these two around the right way. And we're going to connect that to red and black. So I'm actually ignoring this whole upper part of the circuit here, the buttons and the other, and I'm only using this lower part here. And what I've done is I've actually created a slightly different circuit. Now, in order for this to work properly, what I'm going to have to do is resave this because right now it's not happy. So I'm just going to hit save. It's going to overwrite this, and now it's green. Everything's connected. It's reading the chip. If I press the button once, we're going to see that one of the steppers, if we don't get it caught on the wires, is turning. If I press it a second time, my other one turns. Turn and turn. Whoop, there it goes. It catches up. Might have dropped a frame there. I'm not sure. And if I press it again, both are going to turn. And if I press it again, they're going to stop. And again, like the other one, I have the lights turned out. So let me walk you through the program and show you how that works in CircuitPython. In CircuitPython, again, I start with my comments at the top, just like we did before. In this one here, I've got dual stepper test by me, uses 2 stepper motors connected. This is using the QT Py SAMD21. They do make different versions of the QT Py. So this is the SAMD21 running CircuitPython with an AW9523 STEMMA QT expander. If I wanted to, remember I talked about this QT connection here? The QT Py actually has one on the end. If I want to get rid of these 4 wires that I connected here, I could run one cable from one to the other, and I do have some of those cables. I'd be able to hook that up. And a push button was added for test modes because I didn't want to remove all those other buttons. And I only put one on for this one. So it says here, include any helper files. CircuitPython is much more stripped out than Arduino is. It doesn't load in a bunch of stuff on the overhead, so I have to tell it to include time because I need a delay. Include board, which is the communications across I2C. Okay, Walter, thank you very much, and hope you get a chance to watch the rest of this later, but do what you need to do today. From digital I/O, we're going to import digital input, output, direction, and pull so that we can use this push button. And we're also going to include the driver file for the Adafruit AW9523, and we're going to connect it to I2C communications, and it's going to be AW. So we're still going to use that AW name. Here's my push button, it's just push button. I set it to pin 8 on the board. That's on the QTPY board, QT Py. I set the direction as an input, and then I set it as a pull-up. So I'm using the same kind of principle that we used for the other ones. We're using an input pull-up. Create the pin assignments. When we're creating the pin assignments, the 8 pins that we're going to use for the 2 stepper motors, I assign them pins, and again, I'm going to put them on AW, so they're going to go on the expander board. And since this is an expander board, it uses the phrase get pin. So it just says, hey, get these pins. I want to use them, and this is what I'm going to assign them to. So I've assigned those 8 pins to these 8 spots on the expander board. Then I have to tell it, because this expander board can do both inputs and outputs, I have to tell it what I'm going to do. And by default, all of the pins are set up as inputs on the expander board. So I need to say switch to output. So it's going to take all 8 of those pins, switch them to outputs, and then I want them to turn off in their initial state. So I'm telling it, hey, for now, I want the value to equal false because I want them all to be off. So I've set them all to outputs, and I've turned them all off. My variables that I've created one called mode. I've created counter 1 and counter 2. Counter 1 and counter 2 are keeping track of the steps for each of the 2 stepper motors. And then I'm into the program. This is already the program. So all of your setup is handled within this first part of it. It's part of just setting up all your parameters at the beginning. That is also your setup file when you're talking CircuitPython. While true is the beginning of the main loop that you're used to in the or void loop in Arduino. So I'm going to read the button to see if it's been pressed. So if not, push button and the value. So that's the read statement right there. I'm going to say mode equals mode plus 1. I can print the mode so I can put it up here on the screen, which I will show you. And then I can tell it to sleep. So I've actually created a delay so when I press the button, it doesn't read 16 times while I hold the button. I have a half a second to let go of the button, and then it'll kick in. It says here, when in mode 0, turn off all the coils in both steppers. So if my mode is equal to 0, then what I want it to do is I want to set all my output values to false. So this is the same as doing a digital write, except now these are just these pins. I already assigned the AW up further, so I just have to use the straight pin names. When in mode 1, rotate just the first stepper motor. So in mode 1, what I want to do is I want to change my counter and I want to make it equal to +1. I take my counter, if it's equal to 1, set these 4s true, else if, do this if it's 2, else if, do this if it's 3, do this if it's 4. That way it doesn't go and do 1 and then 2 and then it just does it nice. I could probably get away with just if statements. I decided to link them all together. So once it's done 1, it skips the rest. If the counter 1 is greater than 4, set the counter to 0. I'm only going in one direction, so I do my resetting of my counter value here. Then I do the same thing in mode 2. What do I want to do is I want to run the second motor. So I want to do the same thing and I want to set up its pattern. And again, if it goes over 4, set it to 0. Mode 3 is the tricky one. So in mode 3, if counter 1 is equal to counter plus 1 plus 1, so increase it by 1, and then set these values, and then it does number 2, and then it gets to the end. My total sleep time at the end is 1 millisecond, not 2. I don't need 2 milliseconds. I only need 1 in here. That gives it more than enough time to pause. And it says here basically if the mode is greater than 3, set the mode back to 0, and at this point it prints the mode. So let me turn on my serial monitor. I'll do an initial download so we can see what goes on this part. So this is its version of the serial monitor. So basically what happens, it says here, and it says, oh, code PY output, it's ready to talk. It updates really fast. It doesn't go through that compiling process. It's strictly updating a text file. So now I'll press my button, and now I show the number 1, and I see my first stepper motor rotating. I press it again, I'm now in step 2. Mode 2, so my other stepper motor is running. If I press it again, I have both stepper motors running, and I can see that it's in mode 3. And if I press it again, it should go back to mode 0. It went to 4, and then because it's greater than 3, it dropped it back to 0, and it printed out those values. So I can see that it's going through the different steps on the steppers. For the push buttons, it's picking up each mode. It's picking up the steppers. Everything is working very quickly and easily. So this is basically how it works in CircuitPython. The code is simple. It's similar in length. The previous code that we used on for the dual steppers, I think we got up to 176 lines of code with the comments. This is 167 with the comments. Very similar in length. A little easier to do it. I think actually for me, I find the CircuitPython code is a little more logical. Both work. You got to remember that Arduino's been around a long time. A lot of people are using it. So I would say that you could use either one. So if you're familiar with Python or CircuitPython, you'll see this is very English oriented, very simple. If you're used to Arduino, you like this one. Again, for the most part, it's fairly simple. A little different on how I'm setting up. If you noticed in this one here, when I used Arduino, I had to set up the data types. And CircuitPython, for the most part, I don't need to set up data types. It knows what the data types are. So that's some of the differences between them. And they're just a little learning curve. CircuitPython is a much newer language and a very developing language. So it is changing a little bit as it goes. So I hope this is interesting to you. So let's get these going just to, you can see them keep turning. We'll see if I wipe anything out or get caught on anything. That servo's not going to make it. There we go. Now I'll be all right now. So now those servos can continue to, or the steppers, I should say, not servos. The steppers can continue to rotate. So we're able to run multiples with here. So again, I'd like to thank all of you for showing up. If you have any comments, please add them into the comments. We're going to go into the closing here. So if you like this video, please like it on YouTube. It's always nice to get some feedback. I don't mind feedback. I don't mind questions. I try to get to them. I'm getting a little better on answering back on YouTube. And don't forget to send me a message. You can send it by email or on YouTube itself, especially if you want the code. Send me an email. Let me know that you'd like a copy of the code. I'll be glad to send you a copy of that code. I don't have a problem with that at all, and that's in the description on my site, on my YouTube channel, so please do that. But you can contact me also or follow me through Twitter at North. I send out notices when I'm going to do these shows. There's also the YouTube channel, of course. Subscribe to that if you want to. If you happen to come by this and you want to subscribe, please do. I've been getting some subscribers, and thank you very much for that. To those people that are out there, I do appreciate you subscribing. So that's youtube.com/kingernorth. And that's me. I'm kingernorth. So this was Microcontrollers with kingernorth, episode 30. Multiple stepper motors with Arduino and CircuitPython. I hope you've enjoyed it, and enjoy your day. Take care, everyone.